Guys, I'm just going to do a really quick video recapping all of the notes from topic 11, because one of the things that's hard about this topic on properties of triangle isn't that the individual properties are difficult, it's just sometimes hard knowing what to do for which problem or which property you're using at a given time. So I'm going to try to get through a couple of these for you really fast. So the first thing we did was topic 11a, and 11a was about classifying triangles. Okay. About classifying triangles, but we made it a little harder by saying the first thing you're going to do to figure out how many sides are the same is you're going to use the distance formula to find the distance or the length of the side. So the first thing you've been doing is the distance formula. At this point in the year, we're expecting this to be memorized, so you will not be given the distance formula. You need to memorize it. Okay. You can look that up. That's from topic 3 from unit 1. Okay. Then the second thing you're going to need to do is classify as either scalene, which means all the sides are the same length, isosceles, which means two of the sides, or it's technically two or more, but for right now we're just using two sides are the same, and then equilateral, which is when all the sides are the same, or all the same length, I should really say. So really this is all different lengths. Two have the same length, and this is when all have the same length. (11b) was the triangle sum theorem. And the triangle sum theorem tells us that all three angles in a triangle add up to 180. And this is the formula that we use. Now, notice it's that all three angles add up to 180 degrees. It's not that the sides add up to 180, it's that the angle measures add up to 180 degrees, so be careful with that. 11c uses the exterior angles theorem. I'm going to start by drawing you a picture. Well, actually, let me put the theorem first. Or maybe I'll draw a picture. I'm going to draw a really quick picture over here. Okay. So here's my triangle. Here's A. Here's angle B. Here's angle C. We know all three of those add up to 180. That's the triangle sum theorem. We also know that if we have an exterior angle, it's created by extending one of the sides of the triangle. These add up to 180 because they're a linear pair. And in class, we did a proof to show that this exterior angle here is equal to the sum of the remote interior angles. Remote, we just mean it's away from the exterior angle. So this is the interior angle that's directly next to the exterior angle. These over here are the remote, the ones farther away. These are the remote interior angles. So the formula says that the two remote interior angles are equal to the sum of the exterior. In this case, the remote interior A and B. The exterior is D. So remember again, these here are the remote interior angles. And this is the exterior angle. Okay, 11D. (11D) shows us that if I have a triangle with a short side, a medium side, and a long side, then the largest angle is going to be opposite the largest side. The smallest angle is going to be opposite the smallest side. And the medium side angle is going to be opposite the medium length side. Okay? I call this SML. Similarly, if two sides are the same length, the two angles opposite them will be the same length, and that's what the isosceles triangle theorem says, and I'm going to show that to you right now. Okay. So let me start by drawing an isosceles triangle. And an equilateral triangle. Okay. If two sides are the same, it's an isosceles triangle, the angles opposite them will also be congruent. If all three sides are the same, then all three angles will be the same. In this case, in an equilateral triangle, all angles measure 60 degrees. Oh, I just wrote 90. 60 degrees. So an equilateral triangle, all angles measure 60 degrees. Okay. So if I could recap that, it would be like this. If sides are congruent, their opposite angles are congruent. These two sides were congruent, so their opposite angles were the same size. These three sides were congruent, so all three angles were congruent, which made them all 60 degrees. Next we had 11F, and I like to call this, is it a triangle? So if I gave you three sides, how would I figure out if it's a triangle? You're going to take the two smallest, and together they have to be bigger than the largest angle. So for example, if I had the sides 5, 1, and 7, I would take the two smallest sides, and I want to see if it's bigger than the last side. It's not, so it's not a triangle. Now I have 11G. If I have a problem asking for the possible lengths of the third side, I subtract the two sides that I'm given, and I add the two sides that I'm given. And the third side has to be somewhere in between those two. 11H is also about third sides, but this is the hinge theorem. And the hinge theorem says if I have two side lengths that are the same, so for instance, this is the same as this, and this is the same as this. But notice this this included angle, the angle in between the two sides, is bigger. Let's say this is 40 degrees. This one's smaller. Let's say this is 20 degrees. Because the hinge here is smaller, but with the same two sides, this third side here needs to be smaller than this third side here. So if this is triangle A, B, C, and this is triangle D, E, F, then BC has to be larger than EF by the hinge theorem. Okay. 11I is all about mid-segments. Oopsies. Mid-segments. We have two rules about mid-segments. But first, let's figure out what they are. So a mid-segment is made by connecting two midpoints. And our rule is that the mid-segment is half the base, and the mid-segment is parallel to its base. When I think about the mid-segment being half the base, I can think of this two ways. The mid-segment is half the base, or two mid-segments are equal to the base. You can use either of those formulas when you're solving. Okay? So I don't have room to put in the last thing about the angle bisector theorem and the perpendicular bisector theorem, but this should get you started. So these are some keywords that you should look for, right? If you're looking to classify a triangle, here might be your process. If you're asking for the order of sides or angles from smallest to largest, you might use this. If I'm asking if three sides can make a triangle, it might be this. If I'm asking for the length, the range of lengths to the third side, you might use this. So use this as a guide to help you as you're reviewing. And if you have any questions before the big quiz, please let me know.